First of all, I would like to thank Jenn to be a part of this event. And the reason why we are having this interactive EDA workshop is because we had quite a lot of questions regarding how I can start coding in Python and why. And I've noticed a lot of times people really don't spend that much time on EDA or data analysis, which is a very, very important step to think about. So we have decided to conduct this session in two parts. The first of all would be having a code. We have a data set that we are going to do an EDA analysis on, and in Python as well as R. So Jenn would give show us cool, interesting libraries, what you can use for R for the data analysis. Cool. Let's start with today's agenda. As I explained, why to invest time doing data exploration, and then we jump onto EDA in R and then EDA in Python. We'll have some time left for Q&A, so if you have any questions at that time, feel free to drop it in the Q&A box. Okay, so why is EDA important? Jenn, why don't you start with it and then I will join you?
Yeah, great. EDA, exploratory data analysis, what we're talking about today. So it's important because it allows you to get an early understanding of your data. Usually in an EDA, we're getting maybe some summary statistics. We might be looking at some correlations. We're probably going to look at some visualizations, which is really important because summary statistics can't tell us everything about our data. So looking at some visualizations is a really good idea. And basically through this process, we're trying to get an early understanding of what's going on in our data. The exploratory part is really important. We're exploring our data. We're trying to understand what's going on, what are some patterns we see, how do the distributions look of the different variables, what are the different types of the variables, like down to that level of like, what variables do I have, what do they mean, and what type of data is in them? Are they categorical variables? Are they numeric variables? If they're numeric, are they measuring kind of on a continuous scale or on a discrete scale? So we're just really trying to get a good understanding of our data at this point, as well as do some early exploration into what patterns might be there, what relationships might be there, and just get a general sense of what's going on in our data.
Very well said. I could not have added anything more than that. But yeah, that's one thing. It's very important. Also, if you're applying for a job interview, the first thing that you would be handed over sometimes is a CSV file where you have to do an EDA analysis, as well as, maybe train a machine learning model on that. But what the recruiters really want to see is how well you have spent time on your data. And they're really, really interested on that, because if you have a clean data, that's where once you have a clean data, on that you will start building your machine learning model. So you need to have really good data, clean data that really makes sense. So it's very important to have a good understanding of your data and doing a prior analysis on that. Cool. So one question that we have got so far in the series of Kickstarting Your Career in Data Science is, how do you select your next project? That's a very, very hot question that we get every time. So Jenn, if you have any comments on that.
Yeah, so I work a lot in data visualization. And so when I'm thinking about selecting my next project, like my own personal project, one thing I look for is data sets that I'm interested in, or some sort of like topic that I'm interested in, because especially if it's a personal project or a project that I'm doing to build a portfolio, I want it to be, I'm going to spend time on it, and I want it to be something that I care about and that I'm interested in. So that's one thing I do, is if I find, it could be like a TV show I like, or I love to read. So one thing that I do, because I think it doesn't have to be a data set you find, it can also be a data set on of your own personal data. So I keep track in a Google sheet of all the books that I read in a year. And then I like to do a visualization of that at the end of the year. So it can be personal stuff too, like you can keep track of your own data and then do something with it. But I think that's a key thing, is like picking something that you are interested in. And then, because you're going to be spending time with it, and it might as well be something that you like, and have some interest in. And then I think the other piece of that is actually having like quality data. If you're collecting data on yourself, then you have control over that. But if you're just out looking for data, whether it's on Kaggle or World in Data, there's a bunch of different places that you can go to find data sets. The quality of it, I think my video just froze. Hopefully you can still hear me.
Yep.
Okay. Let me just turn my video back on again. Oh gosh. Okay, there we go. Then when you've then if you're out searching for data, it's important to look at the quality of data, like where did it come from, who collected it, was like who's included, who's missing from it, that kind of information. And then you can, through EDA, then you can start answering some of those questions, like you were just saying about like how, like, are things missing? What kinds of inferences could I start to make from this? Because that's another piece of it, like you're doing the analysis is the processing piece. And I think my video froze again. So I'm going to stop talking for a second, turn my video on and off, and let you follow up.
Cool. Awesome. Yeah, very well said. So the first thing is everyone has this mindset sometimes, most of the time, that, oh, I want to do a project which is really, really good, which is some Mang specific project. I want to get into Google, and there should be a project which is, you know, very a Google specific project that would help me land my dream job. But the thing is that there is and there's nothing like that. It's about you, any data set that you have that you're working on, you can decide on any topic that you really like. So the first thing is that keep in mind, you don't need to work on something that you really don't enjoy. If you're, let's say, if you're doing house price prediction and you don't really care about that and you really don't like it, don't do it. Do something that is really interesting. If you're interested in football or any other sports, do some kind of analysis on that. It really doesn't matter what data set it is. What matters is you doing work on that. So at the end of the day, whatever data set you're using, to the time you're doing the right kind of analysis, adding as much plots and graphs you can, it's a good data, it's a good exploration. So really don't care about the project, you know, in the sense, the topic, the data set, it's about what work you have done and how much time you have invested doing that work. Cool. Quickly jumping on how to start the EDA analysis if I'm a beginner, and we would answer this with EDA in R and Python. So I'm going to go show you a live example on how you can start with the analysis in Python, and then Jen can join with how can you do it in R. Yeah. Right, so wait, I will share my screen again.
And I saw we got a few questions. I don't know, do we want to address any questions now or just save them to the end?
We can do it like, let's have it like one, we can share the notebook, take the questions, and then you can, we can answer, have a Q&A, and then you can share it, then have a Q&A, because there would be people asking in both, I guess. Okay. Yeah. Cool. Let me know. You can see my screen. Cool. The first thing I would like, I'm pretty sure the data set and the links to this collab notebook is being shared on your chat. So please have a look. The moderators have shared it. And what you can do is, if you want to find the data set, I've linked it in the comment section here. Also, if you want to work on this or want to add anything in the notebook, I would request you to please do save a copy, do any changes in the save a copy in the drive. If you click this, it will automatically generate a copy of your this notebook, and then you can work or edit on anything else, you know, open a new tab. If you do that, you can just see that the copy is made. You just change the name and you can start working on this one rather than the original copy. Cool. The data set you can find on Kaggle. Okay, you can find the data set on Kaggle here, and the CSV file for data set here. Right, let me see. Okay, cool. So the first thing that we're going to do is, as you can see, the data set is a Penguin data set. So we have just chosen a data set which is easy to understand. It's not very complicated. We didn't want to go deep into complicated stuff. And to be very honest, I started working on it like 3 days back. So I have no idea about what the data set was. And so this is what every person might be thinking, that, oh, maybe because someone has worked with Python, they are experienced with it, they know how to do the stuff. But no, if you're still starting out, it's fine. Very basic steps we are going to follow. It's nothing very complicated. So we're easy for everyone to follow this thing. So Penguin data set, find it on Kaggle or a CSV file data set. It's on the drive. You can download it from there. These are a few libraries which are very common that you're going to find. So pandas and NumPy are a data analysis libraries. NumPy is to deal with arrays. So I'm using 2 to 3 visualization library Feel free to use any other if you are comfortable with that. So it's not restricted to this one. So we'll start. Very basic thing is we need a CSV file, or could be a directory if you are dealing with image data, but there would always be a CSV file even if you're having an image data set. So go and look on that CSV file to see what are the rows, columns we are dealing with, what is there in the data set. That's very important. So what I'm doing is reading the CSV file and just printing top 5 rows of it, just to get an understanding. This is a very small data set, but there are sometimes really large data set with many number of columns. So one thing that you can see is how you can print the number of columns and rows to get a general ideas. So you can just do df.shape. It's a very useful function to use, well, because it will help you understand how many rows you're dealing with, how many columns you need, and there would be sometimes there would be hundreds of columns in some of the data sets if you're dealing with really large data set. So it's helpful to remove the data set or remove the columns which are not really necessary. Fine, let's get more information on the data frame. So we know that we have species because it's about penguins. What are the different species in penguin? Which island they belong to? Their length, their depth, it's their fin length, fin depth, as well as their body mass and their gender. So we can see that there are some non-values, which it means that there is no value over there. So we might not want to use the data where we don't have any value. It's just adding more rows and we might not need it anyways. There's no data there. If you're, okay, I'll come to that later maybe. So if you do df.info, you're going to get information about species as well as how many non-null values there are, because I can see shape of the data set is 344, means there are 344 rows and 7 columns. You can see that there are columns with all of the fields present, but there are few of the columns where not all of the fields are present. So it means there are some rows which have the value missing. We don't want to use that. So what we can do is we can drop those rows which doesn't have the fields, because at the end of the day, we might not need, we don't have the data, we might not need it. But whenever you're dropping the non columns or rows, you need to think about how many you're dropping. Because there are just 10, it's fine. But if let's say if it was around 50 or 60, you might not want to do all of them. You might want to take some more time to evaluate why is it so many rows, how you can replace those values with so that you're not removing a large chunk of data set. So you have to be very careful. So all we are doing is getting more information on how many null values are there, though we do get an idea from this the info section, but very specifically, if you want to get a very quick idea how many null values are there in each columns, we can also print them like that. To remove the drop the rows with the null columns, you can just use this function. So if you're wondering why I've used this one specific function, is because in this data set, when you're loading it, you're going to see that there's one value in the gender section, which doesn't have any value. It's just a dot. So I really thought that it's not very helpful. So I just thought of removing it. But you really don't have to do it. It's something that I've just noted when I finish this entire notebook. You can completely skip it if you really want to. It's nothing that specific. The other thing, as I've dropped the null value rows with null values, now you can see that all the rows which has no values has been dropped. There is nothing. All of the images, all of the rows have some or the other values there. Also, when you're dealing with a large number of data set, it's good to have an understanding what are the columns which are visible, because sometimes if you're dealing with large data set, not all the columns are visible. So it's easy for you to have an idea of how many columns are there, what are the name, and you get it in a very nice list format. So it's easy to have a view of that. So we have got an idea of what the data frame is about. What are the rows? What are the columns we have? And now we just want to get more information of, what about the data frame based on column values. What is the mean? What is basically total number of counts that we have? So just an idea of those values. If you ever want to use, let's say, if you want to know what is the average of what is the average body mass of those penguins, you're going to get a very quickly an idea of the mean or the standard deviation or minimum of these values if you just want very quick analysis on that. So the next one is how many, if you want to understand, okay, we have these many penguins, and out of this 344 samples that we have, how many are there different species of penguins? If you want to get, again, it's good to have, we have a data frame, we have rows of those species, but for our clear understanding, quickly to analyze how many species there are there on the data frame, we can just use a value count. It will, and first of all, give the input of a data frame with your species would be the column name as well as the value count. Will give you a quick summary of how many types of species are there or how many unique categories of that particular column might exist. I've done the same for an island. So they could be, the penguins could belong to different types of islands. So that's what I did, find this unique islands which are given in the data frame. And now comes the most interesting part. I've always liked the visualization aspect of it because, honestly, very honestly, I really don't like looking into these data frames. They're, again, statistics. It's not very interesting and entertaining. But when you're looking into graphs and plots, it's something really interesting because you can actually see or visualize what's happening. So that's what the graphs are. For this specific session, I'm using Matplot, Plotly, and SNS. These are very commonly used visualization tools, but definitely there are more that you can explore and you're comfortable with. Please feel free to explore that. So I'm giving example of one each. So using Matplotlib, I'm trying to understand what's the ratio between, how many are males and how many are females. It's easier to understand by maybe if we use this function to understand how many species are there. So if we can get a count of 50 and 50, yes, definitely. But if you want to just have a visualization so that, especially when you are dealing with a large notebook, it's easy to scroll through. Okay, fine, there is an image. It's easy to, interpret. So we have a ratio of how many are females, how many are males. The next thing that we are trying to do is we are trying to get an idea of how much two values or two variables are dependent on each other based on their species. So that's something we are for this plot. I'm using a Plotly. The good thing about Plotly is you can find these bubbles where they have all these information there. So it's more interactive. It's not very static. So you can definitely go and have a look with Plotly. And so it's the reason why we have used a scatter plot for this. What does this graph means is, let's say we have length and we have depth. And so based on this, we need to understand how much the length. Okay, I think the first thing would be to understand what the length aspect means here. So I'll scroll through it and let me find a log section if they have, because I don't think I've put it here. Can't find it.
I think it's how long their bills are, and then the depth of their bill is the,
okay.
Yeah.
I wanted to have like an image because I think they're there on the Kaggle page somewhere.
Yeah, there is one. I've got the R package thing up, and there's an image on here. Do you want me to just share that quickly?
Yeah, please.
Okay.
I think it would be helpful.
Yeah, so it's this in the data set we're looking at, it's called Coleman, I think, instead of bill, but it's essentially this length of their bill and then this depth of their bill is are the two measurements we're looking at.
Awesome, great. Yeah, that image is very, very helpful. Cool. Let me reshare my screen. Awesome. Cool. So we want to understand how, based on different species, these length and depth kind of are related. So if you think of an example other than this one, it's much more easier, I guess, to think about it. If someone let's say if there is a rat, and rat has a body mass index and as well as a speed index. So we might think that a rat who has higher body mass might not have a higher speed. So we need to understand on a plot section that way. In the same way over here, length and depth, we want to understand how length and depth of the beak of the penguin kind of depends or is related to each other. So if you see that for this species, you might see that most of them has a larger length of the beak, but a lower depth of the beak as compared to this species. They have higher depth but a lower length. So that's what we kind of are able to deduce quickly with the graph, but we might not be able to deduce it with just a CSV or 4 rows. It's just easy for me to, okay, make an analysis based on that. Again, very quickly going to the scatter plot. This is a pair plot, and it's helpful when you have not just one, when you're not just considering one, one column or one feature attribute of your data set, but you want to compare all of them at one go. So it kind of helps you plot a scatter plot to analyze all the features and make a relationship with all the columns which are there in the data frame. So if you see, what these cluster kind of means is how, if you want to do a classification between these 3 species, what are the features that you can use are so separate that we have 2 different clusters, and we can easily say, oh, okay, these 2 are, if this is this species, species A or B, between them, okay, the nose or the body mass is different, or their length of the beak is different. So understanding the relationship between the attributes, which will help us distinguish or classifying between those categories of species, is something that you can use. You don't have to plot this again and again. You can just do it all at once for all the attributes. So if you want to understand how we can separate or classify these 3 species of penguins, just by looking at it, I think this plot, as well as, okay, these 3 plots are really good as compared to other ones, are really good separation between all these species. I can still draw a line over here, maybe not linearly, but maybe in another way, we can still distinguish that, okay, this cluster here kind of is for one category, this cluster here belongs to other. And so for this one, as compared to other plots, I feel this is really not, we won't be able to distinguish between this if we see these 2 features. So body mass and length of the beak might not always be a useful attribute to see when we are trying to classify between these 2 categories. So definitely this is also a clear understanding that, okay, maybe we can look into length of the beak, as well as maybe, okay, this one is the same thing. So maybe looking at the depth and the length, as we just saw here, that then depth of the beak and the length of the beak we can use to distinguish between them. That's what we kind of find here as well. So it's just for you to have a quick evaluation or a quick analysis on what other features you can use to classify maybe different types of penguins or flowers, or any other classification that you're doing. So yeah, I tried to finish as quickly as I could so that Jenn has some time to have a session for herself. I'll quickly go through Q&As if someone has related to Python, and then Jenn, you can take over from there. Hey, Sneha, do we have any question for scatterplot, so Python code EDA?
Yes, so someone's asked, what's the difference between pre-processing and EDA, or are they the same?
I think Jen can answer this if there's something related to Python, because I have to jump off very quickly in some time. So if there's something related to Python that I can answer, I can answer that first, and then Jen can answer all the other questions that we have.
So from what I see, there's nothing specific to Python as so far. So if anyone has any Python specific questions, please do ask that, because Neishka will be more than happy to answer. But so far I see nothing. Oh yeah, sorry. There's a question that says, Neishka, could you talk about the scatter plot chart between length and depth of the beaks? I saw you use some variables like body mass. I wasn't sure how that was depicted in the chart.
Okay, cool. We should talk about scatter plots between. Okay, so I'll share my screen again. Right. So when you are making any kind of analysis, I would not say just take one. You can actually use this kind of plot, but I always prefer a scatter plot like pair plot. And if you're using that, first of all we need to think about is we need to find clusters that distinguish between those species that we are trying to classify. So the clusters which are easily separable for us to distinguish, okay, this section is easily separatable by this section as compared to this one. We can actually make small clusters which are not coinciding with each other. So that's something we need to think about when we are making some analysis, because if they're overlapping, we might not be able to make a clear-cut classification. So that, let's say, if you're trying to get an analysis between depth and length, maybe, so like body mass, if you see here, body mass and length do have some features. Wait, I think we have some more. Okay, this one. Body mass and depth of the beak doesn't really have a lot of common. You can't really form quite a lot of clusters for all these species. If you see that these two species are quite interlinked, so again, we might not be able to distinguish between those two species. That's what we are trying to understand with the attribute sections of these plots, where we're trying to make a clear separation between this is one species or one cluster of people, of flowers, or of penguin, whatever you're trying to classify. And then over here, if you see they're overlapping, the attributes are overlapping, and that's something you don't want, because it will not help you make the right predictions for classification if you're trying to do in future. I hope I was able to answer the question.
Thank you, Neishka. I think that was a really good answer. Priyanka, if you do have any follow-up questions, do ask them, because Neishka will have to leave soon. Okay, there is another Python-related question. So this is, can you please suggest some good Python courses for someone with non-tech background to learn to code for data science and analytics?
Right. So some really basic ones would be just go on Kaggle, and on Kaggle you can find some courses which are just not theoretical courses, but you can actually find data set notebooks, and they have exercises which you can practice, where you can actually practice data visualization, pandas, NumPy. So I would suggest Kaggle. And the first thing, it's free, so you don't have to invest a lot of money. But if you want to invest some money into this thing, DataQuest is also good, and educate.io is good as well. But I feel Kaggle kind of has an upper edge, because first of all, it's open source, it's free. You have notebooks, you can practice coding at the same time, so while you are learning. So I would suggest start with Kaggle, Kaggle notebooks and Kaggle courses. That would be the first thing that you can look into. Kaggle courses are very explained, and you can go into pandas if you want to go into visualization, data science. They have different sections, so you can choose which one you're comfortable with it.
Thank you so much. I think that was a really good answer. Does anyone else have any Python or questions related to whatever Neishka spoke about today? Please do ask them.
Cool. I think Jen can take over from now.
Right.
Cool.
All right. So I'll just answer the one question that we started with, what's the difference between pre-processing and EDA, or are they the same? And then I'll jump into R, and then we can come back to the questions. So I think in some ways pre-processing and EDA are related, but to me, pre-processing is more of any data cleanup that you need to do. So for example, maybe you pull in a CSV file or an Excel file, and your numbers are stored as strings instead of stored as numbers. They're like stored as text. And that would be some pre-processing to extract the numbers from that text and change the data type into a number. Some other pre-processing might come along as you're doing the EDA. So maybe you are exploring your data and getting a better understanding of it. And then you are, and then you find some new some interesting relationships, or you want to make a new variable or things like that. That is some more pre-processing, and that could happen as part of your EDA process. But I think the main difference is that the pre-processing is any changes that you need to make to your data, any manipulations you need to make to your variables, whether you need to make some calculations, make some new variables, things like that, any kind of cleanup that you need to do. And then the EDA is more about the exploration of the data. What patterns do you see? What kinds of relationships do you see? What is going on in your data? Getting a better understanding of it. So that's what I would say is the difference between them. I think they're related, but they are different. So we'll get into R now, and then we'll come back to the other questions. Let me share my screen. All right, so we've already seen this data set, the Palmer Penguins data set. So what that's the data that we were just looking at. It's information about penguins at the Palmer Station in Antarctica, and it was collected by Dr. Kristen Gorman. And I'm going to be using an R package that allows me to read it in, called the Palmer Penguins package. Another package that I'm going to be using is the Explore package. And we'll see how it works in just a second. There's a link to this in the R Markdown document that is shared on that share drive, which I'm going to pull up in just a sec, or a version of it. But this allows us to do interactive data exploration, and it allows us to generate some reports, which is really, really nice. All right, so let me switch over to my R code. All right, so when we're doing exploratory data analysis, we're trying to ask questions, understand variation in variables. So how much difference is there in the data within a variable? We want to check for missing values. And then we also probably want to look at covariation or correlation between the variables. And so as I mentioned, we're going to be using this Explore package, and we're going to be taking data from Palmer Penguins. In R, if you don't have the packages already installed, you have to use install.packages to install those packages. And then every time you only have to do that one time, install packages one time, like you install software on your computer, and then you load them every time you want to use them using the library function. So in this first code chunk here, I'm just going to load my Explore and Palmer Penguins packages and Palmer Penguins packages so I can access my Penguins data. So now we need to start looking at our data. And some basic things that we can do is we can use the view function to just view a table of the data set. And this is, we aren't going to get a lot of idea about like, what does the data look like from this, especially if we have a much bigger data set. But we can start to see, okay, we've got 344 rows. It tells us that down at the bottom here. We have 8 total columns. And we can see the column names here. And what we were seeing in Python for the column length and column depth, that here is labeled build length and build depth. So we can get a basic idea of like, okay, wait, these are our variables. We've got 344 rows, 8 columns. We can get a little bit more information by using a few different functions. One is this str function with the data set inside. That gives us this data set structure. So when we run that, we get the output down here in the console, and then I'm also getting it under my code chunk here, but it's a little bit easier to see down in the console. So what this tells me is it again tells me 344 rows by 8 columns. And it tells me each of the column names, so species, island, build length, build depth, so on. It then tells me what type of variable it is. So this is a factor, which in R treats categorical variables as factors. So that just means categorical variable. And it tells me there are 3 levels, which means there are 3 categories. Same thing with island. It's also a categorical variable with 3 categories, factor with 3 levels. Then I can see build length and build depth are numeric variables. Flipper length is an integer variable. Body mass is an integer variable. That just means that they're numbers without a decimal place. Sex is another categorical variable with 2 levels or 2 categories. And then year is an integer as well. So this is how I can start to get some basic ideas about, okay, what's in my data. Then there's a summary function called summary. So we just run summary with the data set inside. And this gives us a summary information about all of the variables, including the categorical ones. So it tells me that there are 152 Adelie penguins, 68 chinstrap, 124 Gen 2, tells me about the different islands. It then gives me the minimum, the first quartile or the 25th percentile, the median, the mean, the third quartile or 75th percentile, the max, and the number of missing values for every numeric variable. And it gives me the number of missing values for categorical variables too. One thing that you'll notice too here is that for year, it calculates these same statistics. Whoops, well, that highlighted all of it, but it calculates min, first quartile, median, mean, third quartile, and max for year. That's not quite as meaningful because we, year in this sense is somewhat of a categorical variable. In the sense that it doesn't have the same numeric meaning as something like flipper length. So R will treat any numeric variable as just a number, some sort of continuous number variable, and it'll calculate these statistics like min, median, and so on. And then for any categorical variable, it'll calculate the number of rows for each category. And then I just added, I added this one, so this won't be in the code that I shared, but since Neishka showed us how to get the column names, I just wanted to show how to do that here. The names function in R will just print out a list of all of the names of the columns. So this is how we can get some basic information, a basic sense of what's in our data. We can see that we've got 8 columns, 344 rows. We have a mix of categorical variables and numeric variables, and we do have some instances where some stuff is missing. So that gives us a basic understanding, but we want to probably get a deeper understanding of that. And that's where this explore function comes in. So if we run explore, or the explore package, and then the explore function within that package. So if we run explore penguins, it comes up with this interactive window where we can flip through our different variables and see information about them. So for categorical variables, what it's going to do is give us a bar graph of the counts for that category, and then it also gives us a printout of that below, and it tells us the percentages too. We can look at that for island and see the distribution of species among the islands. For numeric variables, it'll actually show us the distribution. It'll give us those same summary statistics at the bottom, but it's also sometimes more helpful to see a distribution of data rather than just trying to look at the summary statistics. And so this is really nice because we can flip through and look at all of the different variables and see their distributions. Another thing that we can do is we can set a target variable. So if we were trying to do this exploratory data analysis to make a predictive model, maybe we would want to be able to predict the species from the data that we have. So if we wanted to do that, we can select target species up here. And you can see now that this has changed a little bit. I have a new graph up at the top, which is showing me the flipper length distribution for each species. And so this is where I can start to see what variables might have differences between the different species. And I can see that, okay, maybe flipper length looks pretty different for the Gen 2 penguins compared to the other 2 penguins. And I can go and look at bill length and other variables as well. Like sex is probably not going to be very different between the species, but it could be, we don't know. But in this case, it looks like we have a pretty, there's not really a dramatic difference between the 3 species of the male penguins and the female penguins. Another nice thing that this can do for us is we can go to the explain tab here. And when we give it a target, it's then going to give us a tree of the variables that it would use to figure out what species the penguin is. So first it would check on flipper length, whether or not it's greater than or equal to 207. And if it is greater than 207, then it's going to check whether the island is Bisco. And if it is, then it's probably a Gen 2 penguin. If it's not, then it's probably a chin strap penguin. And so this is a really nice feature of this, to at least get an idea of like what variables might be important if we were trying to build a model on the species. There's an overview tab, which just gives us some, again, similar information, 344 observations, 8 variables. It does tell us there's 11 rows or observations that contain missing variables, or missing values rather, and 5 variables have missing values. And then if we want to just look at the data itself, it gives us that tab there. So this is super helpful. I think this is a really nice way to do some data exploration, and it's great because all you have to do is run this explore function and you get this whole interactive thing that you can look through. So I need to get back into my R. Oh, I need to close this. Sorry, I can't, the share window makes it so I can't just close that from there. Okay, so we can also use this explore package to create a report of that information. So we use the report function. We have to give it a data file, or our data table rather, which is called penguins. And then we specify the file name and then the file directory or location. So running this, this runs pretty quickly, but just since I already have it run, I'm just going to open it up from my file viewer here. And what this does is it prints out basically all of the information that we saw in that explore interactive piece, but in one single page. And in this case, I didn't set a target. So we're just going to get information about all of the different variables. It tells us in a little table what types of variables we have, how many are missing, the proportion of the rows that have missing observations, the number of unique values, and then just the min, the mean, and the max. Though notice for ones that are missing, oh, for categorical variables rather, excuse me. For categorical variables, it doesn't tell us that because it doesn't make sense for that. For ones that are missing, it actually is calculating that without the missing values, which is helpful. Then we get little graphs for each of the variables, looking at their distributions across their values. So this is super helpful. I think it's a really nice way to get a whole overview. And if you're trying to do some other sort of modeling, like maybe you're trying to do a simulation where you want to estimate bill depths and bill lengths, it's helpful to see this because you can start trying to fit a distribution to it. You can also run this with a target. And when you run it with a target, like the species, so this is what you would want to predict. The top stuff looks the same. It then gives us the distribution of the target, or our variable that we're trying to predict. And then it gives us each variable broken out by the species. So we can start to see if what variables might be important or might allow us to differentiate. And you can see here, this is why island was important, because one island just has one type of penguin on it. And then we can see like the Adelie penguins are on all 3 islands, excuse me. But the Torgerson Island just has Adelie. The Dream Island is where all the chin-strap penguins are, and the Bisco Island is where all the Gen 2 penguins are. And so that's why island came up in that little decision tree it gave us. This doesn't print out the decision tree, but there are other functions. Switching back over to the package documentation. There is this function called explain_tree that will just give you the decision tree. And then we can also check correlations using the explore function again, but this time we are sending the penguins data set to the explore function. And then inside this function, we're putting the 2 variables that we want to compare. So if we run this, it will give us the scatter plot similar to what we saw in Python with bill depth versus bill length. And we can put a target on this as well, and it will add the color here. And certainly you can create plots like this using other packages in R, like ggplot2, but this is a really easy way to do it. And it allows you to just create lots of plots really easily, especially with that report function that will just report out everything that you might want to know about the distribution of your variables and how they might vary by a certain category or another variable. So this is a really helpful function. I really love the explore package. It's what I use a lot, and we only have a few minutes left, so I will skip the very last part I was going to do and go to questions.
All right, so we have a few here. Let me just double check. Okay, so I'll wait for Priyanka to clarify which package.
Oh, I know what package she's talking about.
Okay.
So I can answer that one. Yeah. So the here package, yes, I'm sorry, I didn't mention that one and I just used it. The here package is really useful for setting directories. You know, sometimes when you are either reading in files or writing out files, you have to do things like set your path for your directory manually. And in R, there is a function called set WD, which is like set working directory. And the here package basically avoids the need for that. The here package will look for your project file for your r.rproj file, and it will set the basically root directory or the home directory to there. And then you can use the here package to navigate down from there. I really like it because one, it saves me typing out long file names or directory paths rather than file names, directory paths. And two, if I'm sharing my code with somebody, which I might be to send it to people, or if I'm working collaboratively with someone, they aren't going to have the same folder structure on their computer that I'm going to have on mine. They probably aren't going to save the code in exactly the same location that I am. If we use the here package, and we have R will be able to find exactly where it needs to read files and save files to. I will put also a link in the chat that will hopefully, that might explain it a little bit better than I just did. But here's the link for that package.
All right, nice. And then we have, there's actually a few from, I was wondering if this one was answered already. Kate mentioned that she is moving to a career in data science. They have 10 years of work experience. They completed a data science boot camp, but they're struggling to overcome the looking for someone with more experience challenge. They're very open to entry-level positions. Any tips for her?
It's a good question. I'm sorry, I don't think I have a very good answer. One tip I guess I would have is because you said here that you've worked with data throughout, but not in a dedicated data role. I would highlight in your resume, cover letter, all of that as much as possible, the data work that you have done. Maybe you're already doing that. But if people are saying we're looking for someone with more experience, maybe you can take some of your data experience and kind of highlight that more to get like, see, look, I do have data experience. That I think is my best option right now. I think, well, I guess one other thing would be, I currently, one of my roles is that I work for a university. Universities hire data people, not so much in the data science work is a little bit limited. Sometimes it's more data analysis work. But from my experience there, people do come from all kinds of backgrounds into that work. So if you are interested in working in higher education or at a university, that might be a good way to get your foot in the door. In a data analyst type role, it probably won't be as much data science, but it will be data analysis. So it will be visualization, probably some statistical modeling, not so much machine learning. But that might be a way to get an analyst title on your career, on your resume. And then from there, you could move on maybe to a scientist position. There might be other industries that are like that too. I just currently work in higher ed, and from my experience, a lot of people come into what's called institutional research, which is basically working with data at a university from a variety of backgrounds and not necessarily from like a super technical background. So I guess those would be my two pieces of advice. I'm sorry, I don't have a better answer.
That's a really cool take though, using the educational background. So then we have a few other questions. What is your opinion on LeetCode, since we're talking about jobs?
I don't actually know what LeetCode is. So maybe somebody else on one of the other Women Who Code data science panelists can help with that. I'm sorry, I don't actually know what that is.
I could maybe take a stab at it, or Sneha, what do you feel like? You want to answer it?
Sure. I mean, you can give your answer and then I'll follow up.
My opinion on LeetCode is that I had to do a lot of it to interview for software engineering work, and for data science roles, maybe someone else is better suited to answer for that, but I believe there's, for some companies, at least one, possibly one lead code round or a few, depending on how many interview rounds you have. And it's just testing like basic coding ability. And I'm sure that for data science roles specifically, if that's what you're targeting, they're going to test a few other aspects of your application besides how well you can code. But yeah, it's supposed to be a metric to see how well you can understand like Python or any relevant material and algorithms, data structures, related questions. Kind of a necessary evil for me. What about you?
So I think even I can only answer this from like basically a software engineering perspective. And like you said, I basically used to, and I still do lead code for a lot of these, coding interview questions. So you have a lot of these levels, and it's pretty nice to do questions from there. Especially, I'd say if you're looking for like, software type roles, you should definitely try doing medium level questions. And even as data scientists, that is asked a bit, but if you maybe want to do SQL, I think LeetCode does have SQL practice on it as well. So that's all I'd like to say. Ranjan, would you like to add anything?
No, I guess, Ren and you have completely covered all the things, because LeetCode is majorly known for, software developer roles and very famous for DSA rounds, if you guys know about it. So I think LeetCode is something that you can start off with if you're not very comfortable with a particular language. Like if you're going for like, object-oriented programming, or like you're starting with Python, you can start questions on LeetCode. But yeah, for data science role, I think it's not very, even if you have not done LeetCode, I guess you will be getting a job. They won't be preferring you just based on LeetCode.
Well, I learned something today too. Cool. Thank you.
Nice. So we have another question for you, Jen. How does the application of math differ between R and Python?
That I don't have a good answer to. I learned Python over 10 years ago in computer science classes from an object-oriented programming standpoint before data science packages were available in Python. So I don't really know that too much. There's also, I think part of that question too was about like R is very math stats heavy. So R was created as a statistical programming language. For that reason, and because I have been using for over a decade, I mentioned it in answer to another question about why R. But because why R partially for me is because I just have a lot of experience in it. But the other thing is that R is created as a statistical programming language. The whole point of R is to do work with data, to do data exploration, to do data analysis, to do data visualization, to do machine learning. Like that's kind of the whole point of it. I don't think that it is hard to learn for someone who hasn't taken math in many years. I don't think that that is the case. I think that data science in general does require some like math and statistical knowledge, because you need to be able to understand, the output for your models, understand what makes sense, understand how to read accuracy metrics, and like, does that, what's a good accuracy, what's a bad accuracy, like those kinds of things. It's helpful to have like some math and statistical background for that. I don't think that R itself, learning the programming languages requires that you need to know a lot of math. It depends what packages you're going to be getting into and what kind of stuff you want to do with it. Certainly some of the modeling you might want to do might be very math heavy, but to use the language itself, I don't think requires that. I really like R as an intro programming language, especially for data analysis, visualization, and data science work. I know that a lot of job postings now are asking for Python instead, but I think R is actually very new, user-friendly, and very beginner-friendly from my point of view. So, and I guess there was also like resources for R, and there's another question about good data books. Well, I guess data books, maybe I'll save for a second. I have a lot of recommendations, and I can give you a link actually to some data books that I recommend. But resources for learning R, there is R for Data Science. I also have a YouTube channel where I share R videos and like help people get started in R. I've run a free like intro to R mini course. I'll probably be doing it again in 2023 sometime. I guess I can put myself out there as a resource. But the R for Data Science is another book that is a somewhat intro level. I'm not sure if it's just starting, if it's really for like just from zero, but it is a good introductory resource and a really good resource if you want to use R for data science. And then data related books, I will put a link to my favorite books. Let me just pull up that because I think that's going to be better than me just rattling off titles. So here is my list of data books. It is a little bit there is kind of a general data, and then it is a little bit data viz focused because that's one of my areas of expertise and specialty, but they're there.
All right, awesome. So maybe we can go on to the next question, which is there a way to customize what types of charts go into the dashboard that come up using the Explore package, like if you want a box plot?
I don't think there is with that. I mean, you could certainly then use other libraries in R like ggplot2 and create a box plot. But I think that with the Explore package, it is just going to give you those distribution views, which I prefer in some sense, because I think a box plot can sometimes hide some of the details in the underlying distribution of a data, because a box plot is going to just give you those like high level statistics like median and the interquartile range, which you can get a sense of like how spread out your data is or not from that. But I personally prefer looking at those distributions. I think they give you a little more information. But if you wanted something like a box plot, I think you would have to then go to one of the plotting libraries in R like ggplot2.
All right, awesome. And a follow-up to what you had mentioned about R, is it more popular than Python in academia?
It might be. I'm not from my experience, maybe. I think academia in some sense sometimes is a little bit lagging on some of the I'm picking up some tech tools sometimes. Like a lot of people in my field of institutional research do work with things like Stata and SPSS and things like that, rather than R and Python. And so I think academia can sometimes be a little bit lagging. And yes, I think from my limited experience, I think that could be true, that R is more popular in academia, but I certainly don't have, I'm certainly not, that's just my experience, I guess I should say. Not like, yes, for sure, definitely. But I mean, from what I have seen, yes, I am seeing more openness to R in more academia focused or university jobs than I have seen in kind of the tech industry. But I'm also not I'm not actively job searching, so I only look at postings every now and then.
Yeah, that's a fair point. I mean, for what it's worth, I see R more in like when I was a pre-med, it was involved in more like med-related jobs, med-related data analyst jobs and other jobs like that in that bioinformatics sphere. But that's how I got exposed to R. But we have one more question, and I apologize, we are like 6 minutes over time. If there are any follow-up questions, do you recommend that they email you or type it in the chat? Do you mind staying extra time?
Yeah, I do probably need to head out, but I can drop some links of how people can get in touch with me in the chat. So let me,
Gotcha.
here are, yes,
Mhm.
yeah, go ahead.
Yeah, the last question was just how can one make, so okay, earlier they remember seeing like data get dropped and placing it as true, but before dropping rows and columns, should you make a copy of the data sets? And they said that they make copies.
I think that's a very good idea, especially if you're dropping. I usually actually, yeah, what I usually try and do, even if I'm dropping, replacing data, updating anything, making new columns, I definitely make new objects or a new copy, a new name for the new data set that or the data set that I'm altering. I think that it is good to make a copy. And I think one thing with dropping missing values, it's Neishka mentioned this, but sometimes it makes sense to drop missing. Sometimes it makes sense to keep them in. Sometimes it makes sense to try and impute a missing value and try to kind of like take what you know about the variable where it exists in the rest of the data set and try and calculate what the missing, like replace the missing value with an estimate. So there's a lot of different ways to treat missing values. And I think it's a very good idea to keep the original version and make updated versions of the data set in your environment as you're making changes like removing missing or replacing values or updating things. So I feel like that probably wasn't as clear as it could have been, but thank you. Thanks so much for facilitating. I really appreciate it. And thanks for having me.
Thank you so much, Jen. If anyone has any follow-up questions, can they email you about it or connect with you? Do we have your social media?
There's everything over there in the chat. So yes, feel free to connect with me on Twitter, Instagram, LinkedIn, and I put the YouTube channel there too, which will have some intro to R things. And then I also have my email address. So yeah, thank you.
It's all out there. All right. Well, thank you guys for joining today. Appreciate your time. I think we're going to end the session here. Hope you have a good day. Stay warm.
Yep. Take care. Thank you.